Hello, welcome to 13.3. We are marching through chapter 13. Probability and odds is what we're working with today. So just a few terminology pieces here right when we get started. Defining what probability is. Probability is the measure of how likely an event is to occur. Can something occur all the time? Well, then it's 100% likely. Each possible result is called an outcome. And there are two different types of outcomes. There's those that are favorable, which we call a success. And then there are those that are unfavorable, which we may refer to them as a failure. So we have failures and successes. And the total sample of all the possible successes and failures create what we call the sample space. So it's all those outcomes. For instance, my sample space over here on this colorful wheel that doesn't show up on your notes so colorful would be, I would have 5 outcomes in my sample space because of all the different colors there. So that would have a sample space of 5 outcomes. If I wanted to look at what the probability of red is, well, this is the one red part right there. I would have a 1/5 probability of that being red, which we know is the same thing as a 0.2 or the same thing as 20%. So 3 different formats of the same number. What's the probability of it not being red? Well, I would have to say then my color orange, blue, green, and yellow would be considered not red. So I'd have 4 successes there out of the total sample space of 5, so 4/5 or 80%. Probabilities can be written in 3 ways. We just talked about it: decimal format, fraction format, and the last one, you could write it as a percent. Just looking at this scale, the possible answers for probability lie between 0 and 1, or 0% and 100%, and anywhere on the spectrum in between. When you hit right in the middle at 50%, it's as likely as not. And I think that's just kind of a cool way of saying it. So impossible of getting it would be 0%. Certain that this outcome will happen is 100%. The probability of success and failures could be written or defined as this. So probability is what the P stands for, S for success. So we're looking at the number of successes compared to the total number of successes added with failures, which would create our whole sample space. If I want to look at the probability of failures, then I would put my failures on top over the total number of successes and failures on the bottom. And that'll give us probability. So one thing we know for sure, if I added up the probability of successes plus the probability of failures, it would have to equal 1, or it would add up to 100%, because either it is or it is not. No in-betweeners. Odds are one that people have trouble with. Odds just compares the successes to the failures. So here they're defining it as the probability of a success to the probability of a failure. That's one way of doing it. I also could just compare it as the successes to the failures, number of them to number of them. So notice how odds does not include the total amount. Each letter of the word probable is written on a separate card. The cards are placed face down and mixed up. What's the probability that a randomly selected card has a consonant? So what are the probability? From the word probable, a consonant are all those things that are not vowels. So this would count, R would count, P, that's a B, B, and L. So I would have 5 consonants, right? And there are a total of 1, 2, 3, 4, 5, 6, 7, 8 total letters. So my probability of a consonant, I'll write it all out, is equal to 5/8. If you wanted to convert it to decimal, you certainly could. What are the odds that the card is a consonant? Now remember, odds compares successes to failures. So I had 5 ways of having a consonant selected, and that would mean then that there were 3 vowels involved, right? Because either it's a consonant or it's a vowel. So it's a 5 to 3 odds. 2 number cubes are rolled, but what is the probability that the difference between the 2 numbers is 4? Well, what's the size of a sample space if I'm rolling 2 dice? Well, remember there's 6 on the first dice, and there's 6 ways of outcomes on the second dice, so that gives us 36 total outcomes. Now, what's the number of favorable outcomes? Being the ones that have a difference of 4. Well, if I just kind of reveal that chart, here's all the possible outcomes for dice. For these are 2 dice being rolled. I could roll a 1-1, a 1-2, a 1-3, and so on. Which ones have a difference of 4? 5 minus 1 would be a difference of 4. 6 and 2 have a difference of 4. Losing it here. 1 and 5, 2 and 6, and I know there's some more. Difference of 4. Maybe that is it, huh? So I have 4 possible favorable outcomes. The probability would be 4 compared to the total 36, reduce the fraction, and we'd have a 1/9 probability. I'm having a hard time getting this screen to go forward, you guys. I'm going to pause.